again. So as you may have noticed from a few of my other videos, we've just been following the examples that come with the SparkFun Inventors kit here. So we haven't really made anything of our own, but that's about to change. So today's task is to simulate a robotic elbow joint. So an elbow, if you look at your own elbow like this, we have 1 degree of freedom, right? We can only move this way. You move this way with your shoulder, and rotation comes from the wrist. So the elbow itself just has the one motion. That's called 1 degree of freedom, and that we can simulate with this guy right here. So if my arm is like this will spin, and it looks like an elbow, right? So that should be pretty easy. Now we've already worked with this servo before, but to control it, I want to do something a little different. I want to take some buttons and have it so that when you push a button, push say this button, it moves one way, and then push this button, it moves the other way. Okay, so that'll be combining what we learned about buttons when we controlled the RGB LED, or no, it was just an LED that we turned on and off, and then combining that with our servo controls that we've done just recently. So I've got about 10 wires to hook it all up here, and I've got a couple of 10,000 ohm resistors to be able to put the buttons into the circuit. And then to simulate the forearm and the upper arm, I've got these chopsticks. I live in Korea, so chopsticks are plenty, so I'll just use these and kind of tape them on here. And then just to make it look a little nicer, I'll use this paper and cover it up and make it look a little nicer. So why don't we get started building this circuit? Alright, so as you can see here, I've separated out some of the wire colors here to make things a little easier. So what I want to start with, I guess, is these push buttons here. So it kind of doesn't really matter how high you put them, but let's try and put them up here somewhere. Okay, so we're just going to jam these guys in here. Just make sure you get them down nice and tight, like that. Alright, and I'll do this guy too. That's a little close. There we go, so I got them both in there, right beside each other. I think they're in down nice and tight. Okay, and then we're gonna hook up the resistor for it also. So that just matches up. You can see the bottom pin there, and then that'll go into the positive portion here if it wants to go in, which it doesn't. There we go. All right, and then same on the blue one. That one up too. Oops, put it on the hole there. Alright, so we've got our wires, our buttons and our resistors, so it's time for the wires. So let's do the blue one first. We're gonna hook this other pin up here. We're gonna hook that guy up to the ground position. And then do the same for the yellow. Ta-da. So this allows it to read the state when you push the button, right? It'll change the, if it's on ground or getting the voltage so that we can read it. There. So now, why don't we hook up the blue guy to its pin to be able to read it. So the one that you put the resistor on, you put the wire in there. And then I think we're gonna hook this up to pin number 12. There. And then the yellow one, same thing, the resistor, and then hook it up to pin number 11. Oops, I missed by 1 there. 11 and 12. So there we go, we've got our buttons hooked up all nice. And we can read them on the board here. So now, what else do we need? Well, of course, we're going to need our power and ground, so why don't we hook that up? We'll use the 5 volts here and hook that right into the positive one. And then our ground will also go in. Okay, so that should let our buttons work by themselves, with a little programming, of course. But we also need this guy. So I already did the paper and chopsticks, like I said. Got a little arm here going. So when the servo moves, it should bend back and forth. So we need to hook up our servo. So I've got these guys here. I just color coded it so the servo wires have a black, red, white scheme going on here. So I just picked some wires to match. Okay. So I'll put the servo into the board. Again, it doesn't really matter where, as long as they're on different ones here. Okay. And then this white guy is the control one. We're gonna put that on, let's say, number 7. Sounds good. There we go. So that should allow us to control our servo as long as we give it some power. So let's do that here. Ground to ground. And power to power. There we go. That's our complete circuit. So we got our arm hooked up. We can push some buttons to control it, but we need to control that with some behavior in our IDE. So why don't we take a look at that right now? Alrighty, here we are in the IDE. So you're asking, what's this program here? This is one that I wrote myself to be able to control what happens with our buttons and our servo here. So yeah, there's no example this time, but I'll put a link to it, I guess, in the comments or somewhere that you guys can find this code if anybody wants to use it. So yeah, I had to write this for my robotics programming course, so I've got some comments here just explaining. So I'll just go over it quickly with you so that we can understand what's going on here. So first thing we need is our servo library to be able to control that servo, so we don't have to program it from scratch. Then we've got a whole bunch of constants here, one for each pin, and I have these move and delay values for the servo just set to whatever, so they're easy to change if you want it to move faster or slower with the button presses. And then I've got a variable also for the servo position. Okay, so we get our servo ready to go here, and then we enter our setup. We set up the pins for the buttons, attach the servo to its pin, and then I have the servo move into 90-degree position just to start us off. And here I've got this serial going just in case we need to debug. Hopefully I won't need it because this program shouldn't be too difficult. So as we go into our loop, we're going to need some variables to watch our button state. So first thing we're going to do, read that button state. Then we're going to use our conditional logic to check it. So basically this one says if button state is pushed here, button state 1 is pushed and button state 2 isn't, then we're going to move the servo in the positive direction. And if button 2 state is pushed and the button 1 state is not pushed, then we are going to move it in the negative direction. So basically these two will allow it so that you can't push both buttons at the same time. And of course when none are pushed, nothing happens. So you can only push one at a time. So we're going to take these values of our servo move and add it or subtract it to our servo position. And then we're going to make sure it stays in the range of an elbow by just constraining it to the value of 0 to 170. So the servo can actually move into 180 degrees, but if you actually look at the bend of your elbow, it obviously doesn't wrap right back around on top of your upper arm. So you got about 170 degrees of motion, just so the two arms don't overlap, because that would be kind of impossible. So once we've got all that figured out, we just write the position to the servo, give it a little delay so it can move there, and then I have these print commands so that we can just see what's going on with the buttons and the servo position. And that's it. So why don't we cook this up here and see how it runs on our little circuit. So here we are with our program running and loaded up. We've got our arm in the 90-degree position here, and I've got the serial monitor running, so we can see that the button states are 1 and 1, and that means they're not pushed down, and that the servo is at 90 degrees. So here we go, I'm going to push the yellow button, that should be button 2, and oh, look at that, moves it away. And if I keep pushing, it's not going to go beyond that 0 position. Now if I push button 1, push it up, just short taps, move it slowly, okay, or I can move it all the way, and now it's at 170 degrees, and can't go beyond that. So there we go, we have a nice little robotic elbow. Look at that flex. Oh yeah, pipes. There we go. So that was a lot of fun. Pretty easy circuit to build, just combining some of the stuff that we've done in the examples already. Okay, and this is me saying goodbye.